In recent years, violent floods have hit coastal towns all around the world. Monsoons, storms, cyclones, and hurricanes. These extreme events, which cause disasters, have resulted in thousands of deaths and forced the displacement of thousands of people. Why are some cities more in danger than others? What are the mechanisms at the origin of these flood disasters? Is global warming the only cause? Since Hurricane Sandy wreaked havoc and flooded New York in 2012, scientists all around the world have been trying to understand the causes of these disasters.
Obviously, everybody is aware at this point that this is going to be a big and powerful storm. And all across the eastern seaboard, I think everybody is taking the appropriate preparations.
On the 29th of October 2012, Hurricane Sandy is getting dangerously close to the east coast of the United States and is threatening New York. The forecasts are alarming. The waters could rise by 5 meters. All public spaces, airports, subways, tunnels and bridges have been declared off limits. The mayor of New York declares a state of emergency. He gives the order to evacuate more than 375,000 people living in the floodable areas.
Back in 2005, I said New York City was going to be flooded. It was not a question of if, but when. Now, I couldn't say exactly when, and nobody else on this planet could say exactly when, but I knew it was going to happen, and it happened.
Fires break out, hospitals are evacuated, people go missing. The flood plunges the city into chaos, causing many casualties. Yet at the level of the planet, such events occur all the time. In fact, flooding is considered as the most destructive natural catastrophe.
Well, coastal floods occur very widely, and they cause tremendous damage and actually mortality. I mean, 200,000 people have been killed in the last 30 years from coastal floods alone. There have been a lot of major coastal flood disasters over the last few years. In 1991 in Bangladesh, about 138,000 people are estimated to have died. In Burma in 2008 in Cyclone Negriz, about 138,000 people again were estimated to be killed. And more recently in the Philippines in Typhoon Haiyan, 6,000 people were killed. And those are just a few examples. Even in the developed world, people have died. In Hurricane Katrina, about 2,000 people were killed. In about 800 of those were in New Orleans. And in Cyclone Sandy, about 200 people were killed. More and more people are moving to cities. Globally, now more than half the people live in cities. That happened fairly recently, moving from human beings being a rural sort of species to being an urban species. And most of those, or many of those cities are actually on the coast.
Nowhere in the world is safe from flooding, but the origins of these cataclysms vary from region to region. In New York, for example, it is a very special phenomenon which caused so much damage.
Sandy, it was not the winds, it was not the rain, it was the storm surge, the ocean coming up higher, much higher than normal, and washing ashore, going into all the little harbors and all the little rivers, and flooding and finding the vulnerable low places and flooding all around. And that's why it was so bad.
Out at sea, hurricanes sometimes provoke violent winds which push the surface waters towards the coast. They generate a marked increase in the sea level. a sort of destructive superwave, which is called a storm surge. But in the case of Hurricane Sandy, other things worsened the situation.
What is the stage of the tide when the hurricane hits? And for Sandy, it hit at high tide. But also, there was a full moon. Every 2 weeks, there's an extra strong tide. We say a spring tide. And it just so happened that not only was the tide high, but there was extra high tide due to the moon. And then the storm hit. And that's why the surge was so damaging.
I've been coming to this beach my entire life, over 40 years, and I've never seen it like that since that day and certainly before that day, where literally the whole ocean, crashing waves, was just inundating and moving into this entire area. It looked like a tsunami, just this relentless storm surge pouring into the Rockaways, and it was nonstop. It just got worse as the evening wore on.
I'm often asked, what is the difference between a tsunami and a storm surge? A tsunami is caused by an undersea earthquake. The seafloor vibrates, a big earthquake, and it creates a big wave that travels at very high speed, maybe 700 kilometers an hour. And as it comes close to the land, it gets higher and higher and stronger, and it breaks. And then it shoots inshore and creates a huge amount of destruction and death. That's a tsunami.
In New York, the storm surge hit the city at night. The next day, the inhabitants discovered the extent of the destruction.
We saw a range of impacts, really saw failures of our infrastructure system and really highlighted how our infrastructure is linked, and the power systems were impacted, our transportation systems were impacted with the tunnels being flooded, our telecommunication systems ultimately went down, we had gas lines because of a breakdown in the supply chain for our liquid fuels network, and of course the impacts on people and neighborhoods were just as severe.
It's interesting how much damage there is in America during floods because they don't have good defences. I'm always amazed that they don't have better defences because they have the money, they have the technical knowledge, but they choose not to use it.
People in authority often say, oh, it was a very rare event. It will never happen again. I say, no, no, no. It will happen again, and it will get worse and worse because as the climate changes and the sea rises very slowly but comes up, 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 the danger will get more.
In recent years, a great deal of research has been carried out to better understand the different parameters which cause such extreme floods. According to the specialists, global warming will probably amplify these events in the future.
Well, we have another problem which is probably going to be the worst of all, which is the sea level rise due to climate change. Sea level has already risen by approximately 20 centimeters since the late 19th century. And this rise has accelerated, and it will accelerate further due to the ongoing global warming. You know, maybe to many people 1 meter of sea level rise doesn't even sound much, because on a calm day when you stand on the beach and you think, okay, water is 1 meter higher, it wouldn't make a difference. When it really hits you is during a storm surge, because of course a storm surge already starts 1 meter higher than without the sea level rise then. And it actually runs up more than 1 meter higher because there are some effects like reduced friction in the higher sea level that make a storm surge run disproportionately higher when you start off already with an elevated sea level due to global warming.
Our planet is warming up, and the waters in the oceans are constantly rising. However, some regions of the world are more affected than others.
This shows the pattern of sea level rise since the year 1993, and it shows that it has risen in most places, but not everywhere. Here in the Eastern Pacific, we see an area where the sea level even has dropped in this period. But on the other side here in the Western Pacific, it has risen much more than average, because obviously the trade winds have increased. They're pushing the water over here and piling it up on the East Asian coasts.
In addition to being located in vulnerable areas, the topography of some coastal towns and cities also increase the risk of flooding. This is the case of the big cities situated on deltas.
And these deltas are incredibly flat. You could go 100 kilometers and the elevation ups and downs would only be a few meters at most. So they're extremely flat. So putting a city on these flatlands is rather easy to do. This is a collection of many of the deltas of the world. The deltas are the land surface where the river's water has brought the sediments to the coastline and accumulated in these large deposits. We have Tokyo associated with the Toni River and Shanghai associated with the Yangtze, and we have Ho Chi Minh City besides the Mekong, Bangkok and the Chao Phraya. We have Kolkata and Dhaka on the Ganga Brahmaputra, Karachi beside the Indus, and we have Alexandria and Cairo on the Nile. We know that in the last 30 or so years, sea level has been going up around 3 millimeters per year. 3 millimeters per year is quite small. And so, yes, in the long term, 50 years, 100 years, you want to make sure your shorelines are protected.
By closely studying these deltas, researchers have discovered an unexpected phenomenon.
We would put instruments in the rivers, we'd put instruments in the coastal ocean. We would be monitoring how the channels shifted around and how the sediments. We found that the tide gauges suggested that the deltas were sinking on average 4 times faster than the other areas. And so we knew something was up. Something on the deltas was happening.
Situated on the delta of the Chao Phraya River, Bangkok is an impressive city, crisscrossed by 2,600 kilometers of canals. It is an astonishing mix, a cross between a modern metropolis and a traditional village. In just a few decades, the Thai capital has grown considerably, and this growth has had a substantial impact on the city.
"35 years ago, the population of Bangkok is perhaps like 4 or 5 million. But right now, it's about 10 million, more than 10 million. So people need water. Let's look about 30 years ago. At that time, the air is really clear and really clean. So it's okay to use, precipitation or rainwater and store in each house, something like that. But, some pollution coming because the city is getting bigger. So it's difficult to use the rainwater, for supply, for drinking or for use or for daily supply. So people start to rely on, underground water. So when we have over pumping of the underground water, the problems start.
Because of the excessive pumping of water, the city is sinking. A phenomenon called ground subsidence, many traces of which can be seen in the streets.
So this is the evidence of ground subsidence. Okay, this pier is actually on the pile. Okay, this is the foundation, and then this area is actually on pile foundation, but this is on ground. Okay, so these two areas used to be the same elevation. Okay, but now because of the previous groundwater pumping, so this one is settled. Okay.
Everywhere in Bangkok, the ground moves and subsides.
if you see this evidence of ground subsidence, okay, you can see the barrier is not even. Okay, it's like a wave. This is because the barrier is located over the foundation of the highway over here. In between, the barrier is not on the foundation, it's in the soil. So the ground actually subside, but the foundation of the highway is not subside. Every year or 2 years, the Department of Highway have to come here and filling more asphaltic concrete.
The entire city is affected by the subsidence phenomenon. Some areas were particularly affected during the terrible floods that hit Thailand in 2011. That year, the monsoon poured close to 16 billion cubic meters of water onto the streets of Bangkok. The protective dikes burst, and entire streets remained underwater for several months.
People's houses were being damaged, people's cars were being washed away, people's fields were being flooded, agricultural fields on the outskirts of Bangkok. At one point, about 12.5% of the land in Thailand, agricultural land, was underwater.
From north to south, Thailand's many rivers flow into the river Chao Phraya. All these mountain waters, from the north, flow towards Bangkok and into the Gulf of Thailand. Swollen by the monsoon rainwaters, they are one of the causes of the major floods in this delta.
If the three sources of water, we call it three sisters, meet the same time, same place, exactly the right moment, we're in trouble. The first sister is the water from the north. The second sister is water from the high tide. The third sister is water from the sky, the angel. Imagine when the high tide taking place and the water from the north coming down here, it's already almost 2.5 or 3 meters high. And imagine if the rain come in the city, both sides, how could you pump it out?
In 2011, the water built up, and there was no way to evacuate it.
In the past, Bangkok had networks of canals and natural waterways that would serve as natural drainage. So water flowing from the north through Bangkok to the Gulf of Thailand, with more people and housing, construction, infrastructure. All of those networks of canals and riverways and waterways are pretty much blocked or disappeared. You have the international airport, or you have the industrial estates built in floodways. I think if you look at the root cause, it's the urban land use.
To accommodate the growing population, new housing has been built in areas which used to provide drainage for the city during the monsoons. Urbanization has completely transformed the landscape of Bangkok, rendering the city more vulnerable to flooding.
We realized that the flooding is actually occurring in some area where there was a factory, okay, that used the groundwater pumping up. And then we start to do the monitoring of the ground subsidence in each area of Bangkok. And we found that 30 years ago, the ground subsidence rate is about 10 centimeters per year, which is quite a lot. So then we're starting to enforce not to use underground water, or promote not to use underground water. And the ground subsidence rate is getting better, from 10 centimeters to 7 to 5, and up to now, before it's completely, we have about 3 centimeters per year. The bluest one here is the ground elevation of Bangkok that is actually under the seawater. This area is actually sunk because in the past, there might be some groundwater pumping a lot. In Bangkok, the groundwater pumping is limited. So the factory is actually moved out near the shoreline and do the groundwater pumping because it's still allowed at that area. It means that the shoreline is subside, okay, creating the intrusion of the seawater inside.
The sea level is rising, and at the same time, the coastal lands of Bangkok are sinking. In this area, the waters have encroached by 5 kilometers in 20 years. Surrounded by the sea, a temple stands alone. It is the last vestige of the receding coastline. The monks have fought to preserve it.
สมัยที่เข้ามาอยู่แรกๆยังมีคันดินเป็นถนนเดินออกมามีบ่อกุ้งอยู่หลังวัดปัจจุบันนี้มาอยู่ไม่เท่าไหร่แค่ประมาณ10 กว่าปีนี่ก็หมดแล้วไม่มีอะไรเหลือใช่ไหมคันดินล้มพังก็ต้องทิ้งที่ไปอย่างเงี้ยเรื่องนี้มันเกิดมาประมาณ 30-40 ปีพื้นที่ถูกกัดเซาะเนี่ยมันก็เหมือนเราใช้ทรัพยากรธรรมชาติมันมากไปไหมใช่ไหมเราใช้มันแบบไม่ได้สนใจอะไรแล้วใช่ไหมอย่างชายทะเลเงี้ยตามหลักมันต้องเป็นอย่างนี้แต่มันไม่เป็นเรากลับไปทำแบบนี้ถ้าเราปล่อยให้มันเป็นไปตามธรรมชาติอยู่ไปตามธรรมชาติมันการเสียหายมันก็จะไม่เร็วมากขนาดนี้ใช่ไหมมันก็จะมีป่าชายเลน
Behind the temple, only a few inhabitants remain in a village which is retreating because of the sea. Samon Kengsamut, the chief of this retreating village, faced with this environmental disaster, is fighting to save what's left of it.
แล้วก็โบสถ์เนี่ยตอนนี้ก็จมลงไปเกือบวาแล้วประมาณ2 กิโลถึงชายทะเลเพราะว่าเขาต้องไว้เผื่อเนื้อที่ไว้เขาไม่ได้ไปปลูกชายทะเลเด่งเลยนะคะเขาจะเผื่อไว้ค่ะแต่ก่อนเราจะอยู่กับพื้นดินนะคะนอนกับพื้นดินอยู่กับพื้นดินพอน้ำมันสูงขึ้นเราก็จะยกพื้นขึ้นสักศอกหนึ่งสักเมตรหนึ่งแต่ตอนหลังมันหนักเข้าเราก็ยกสูงขึ้นเป็นวานี่คือปรับสภาพที่เราต้องอยู่ไงเราต้องถอยเราต้องล่นนะคะตุ่มมันจมเราก็ต้องหาอะไรมาโถมขึ้นให้มันสูงคือปรับสภาพต้องอยู่กับมันให้ได้ไงก็พังมาก็อพยพไปนะคะพังมาก็อพยพไปเพราะว่าแต่พวกเราเนี่ยเราจะไม่ไปไหนเราจะสู้อยู่ตรงเนี้ยเพราะว่า
The former village of Samon is now underwater. These half-submerged posts are the remaining visible traces.
So this is the area, or this is temple that is a symbolic, showing that in the future, there must be a possibility that the water will not stop here, but the water might going into the city, into the Bangkok area, if we do nothing.
No one imagined the city could sink at such a rate, with parts of the coastline of Bangkok disappearing even. Is the Thai capital the only city concerned by this new threat, or is it just one among others?
If we go around the world, we see that really substance is mainly an issue in Asian cities. Bangkok is maybe a classical example where the center of the city has sunk 2 or 3 meters in the 20th century, making it much more prone to flooding. Tokyo has sunk up to 4 meters in the 20th century. Not the entire city, but the bit of the city built on the delta around the port has gone down up to 4 meters. Osaka in Japan has gone down 3 meters. Tianjin gone down 2 meters. Shanghai has subsided 3 meters. Jakarta in Indonesia has subsided 4 meters and is still subsiding very fast today. Manila, probably a meter. Calcutta and Dhaka, we're not really sure, but they're almost certainly going down. And then places like New Orleans. New Orleans has subsided up to 3 meters and is continuing to subside. Vancouver in Canada, areas there have subsided in excess of a meter. And so all these cities I've named have become much more vulnerable to coastal flooding because of this substance, without any consideration of other changes.
Everywhere in the world, cities are sinking because of the excessive pumping of groundwater. But for the big cities situated on deltas, other factors worsen this subsidence. In fact, the ground in these regions has a natural tendency to compact. In the past, the rivers partly compensated for this subsidence by bringing new sediments. But by building dams, man has upset this delicate balance.
Sometimes when we had dams put in, eventually that sediment was no longer able to get to the coast. It was all being sequestered behind the dams in the reservoirs, and then the shoreline was shifted landward. And we've been building one large dam on Earth every day on average for the last 130, 140 years. And you see in 1800, there were just a very few dams. And you will see in red where new dams are forming, first in the US, Japan, India. So the issue of dams is very much part of this story.
By diverting the waters of the rivers with dams and by pumping greater quantities of groundwater, man has caused a great deal of damage. Yet in spite of the increasing number of floods, the growth of these huge cities seems unstoppable. Located on the Yangtze Delta, Shanghai is a symbol of the race for economic development. With a population of 23 million, this city is the most populated in China. It embodies Chinese success and aims to become the leading financial hub in Asia. As a result, Shanghai continues to grow. Its expansion is limitless, in spite of the threats from the skies. Life in the city has always been marked by the taifeng. This word, which terrifies the population, is the Chinese term for tropical typhoon. These typhoons bring violent winds and torrential rains. They regularly wreak havoc in the city.
上海的洪水风险还是比较高的，主要是有梅雨型的洪水跟台风型的洪水。我觉得大自然呢也确实是已经发出了一些警告，比如说这几年的城市洪涝灾害特别多，可能还没有准备好。就像去年、前年发生的那个菲特台风，统计的话，13年上海市的这个灾害损失达到了10亿人民币。如果海平面上升的话，对上海最直接的影响，它是抬高了近海海域的这个最高水位。最高水位抬高以后呢，就是说市区内的这个涝水也好，还是上游的洪水也好，它就很难通过这个赶潮型的河道排出去，这个对它是最大的一个影响。
Shanghai is now faced with a huge problem. In cases of massive flooding or strong tides, the canals will be unable to evacuate the surplus water. To minimize the damage, the Chinese have built a barrier.
这里建了一个挡潮闸呢，就是说是为了黄浦江那个潮水进入这个苏州河。平时的时候，它这是卧在水底下的，这样子不会影响它的景观。然后每天大概早晨的时候，它就会开启一下啊，为了挡这个潮水。
This mobile dike protects an area which has sunk by more than 3 meters in 100 years. This subsidence is due to the excessive pumping of water from the water table. Since the 1920s, the Chinese authorities have measured the spectacular sinking of the city. To study this phenomenon, Shanghai has created a ground subsidence institute, which is the only one of its kind in the world.
在上世纪60年代是上海地下水开采最严重的时期，同时也是地面沉降最严重的时候。这个是我们采用了3维地面沉降模型模拟的不同时期的地面沉降的一个动态变化情况。我们可以看到是从60年代一直到2010年，不同时期的累积的地面沉降量的一个3维模拟图。可以看到地面沉降在持续不断的在发展，但是在通过我们采取了地面沉降的一个防治措施以后，地面沉降的一个速率和它的一个变化得到了一个缓解和控制。
It was only in the 60s that measures were taken with laws regulating the pumping of water. The Chinese were the first to recognize the scale of the subsidence.
地面沉降是一种不可逆的，而且是长期客观存在的一种。地面沉降主要对于城市的高层造成了严重的威胁，同时对我们城市的一个基础设施造成了严重的一个影响。上海从1921年发现地面沉降以来，地面沉降累积的沉降量已经达到了接近了3米左右，平均沉降量在2米左右。
To keep a constant watch on this change, the city has built an extensive surveillance network.
这个是我们上海的一个地面沉降监测网络，其中包括了就是37个地面沉降监测站，我们这是其中的一个。这个呢是我们监测不同深度土层沉降变化的一个监测标组，而且我们目前也已经完全实现了自动化监测的这么一个目的。那我们现在看到的就是地下水位监测井和分层标组的一个监测现场。分层标组呢可以监测200多米深度的土层的一个沉降变化。目前呢，地下水开采量年开采量达到了1000万吨以下，我们的地面沉降量也达到了6毫米，控制在6毫米以内这样的一个效果。
In the meantime, construction work is continuing in Shanghai, and the threat of ground subsidence doesn't seem to stop the architects. For Xin Tonghe, the construction of skyscrapers is a symbol of the ambition of this major Chinese city.
对上海的愿望，希望它成为世界一流的城市。我曾经到过世界许多城市，我相信上海可以赶上。同时还有一个感情上的，就是希望上海的文化、上海的建筑文化、上海的人文还是能够继续的延伸下去。我自己呢也参与了从几十米做到我们金茂大厦跟美国一起合作的这个超高层的建筑。上海这几年可以说30年内，我们从121栋的高层，只有过24米的高层，发展到现在1000多栋，我们最高的已经到692米，我应该觉得是一个骄傲。
Since 1966, pumping from the water tables has been more stringently regulated in Shanghai. Yet ground subsidence continues at a rate of 6 millimeters per year, and many buildings Qin Honghe is proud of are being blamed. Some scientists believe that the huge weight of these new skyscrapers is worsening ground subsidence. No expert is willing to comment on this at present. Yet, this information has been officially published by the Institute for Ground Subsidence in Shanghai. In recent years, with the launching of large-scale urban construction, land subsidence has accelerated. In spite of the dangers, buildings continue to be built. The Chinese dream seems unstoppable. Elsewhere in the country, with increasing urbanization, new urban centers are developing. All of these urban development plans ignore the warnings and run the risk of causing ground subsidence, as in Shanghai. In Japan, the Greater Tokyo area has a population of 37 million. It is the biggest urban center in the world. It is also among the coastal cities threatened by flooding. For more than a century, the Japanese have been fighting to protect themselves from flooding.
In 1910, we had a very big typhoon which came up here, and we got a very serious flood. The government of the time decided to excavate this diversion channel so that the city would get rid of the flood. So therefore, this riverbank was constructed 0.5 meters lower than the other side, so that swelling water can overtop this riverbank. That's because the area behind the river wall was completely rural.
In the past, a buffer zone provided a means of evacuating floodwaters. It was covered in fields, but due to the lack of space, people settled these fields in the middle of the 20th century, thus creating the Koto district. And in the same way as in Bangkok and Shanghai, the pumping of groundwater has led to the subsidence of more than 120 square kilometers in the center of Tokyo.
2 meters above my head, there's a sign saying that the original ground level in 1918 was that. So the current average seawater level is here, which is still higher than me. And now I'm standing on this ground. So this indicates that here is a risk. So this pole was constructed here just to remember the risk. Thanks to the laws that were enacted in 1970s, ground subsidence due to excessive pumping of groundwater has stopped. So there's no worry about further subsidence. But once we get the land subsided, there was no hope that we can get the original ground level recovered.
For more than 40 years, the Japanese have managed to contain the subsidence caused by man. But scientists have identified another cause behind this subsidence. Japan is regularly hit by earthquakes. On the surface, the damage can be considerable. But deeper in the earth, earthquakes also provoke an amazing geological phenomenon: liquefaction.
First comes a big shock. Then it is followed by liquefaction. Liquefaction is a phenomenon that occurs in loosely deposited sand. We have loosely deposited sands along the coastline or within man-made reclaimed lands. So we have granular fabric
of sand, which is not strong, and the fabric is completely filled up with water. Once a big earthquake occurs, this loose fabric loses its strength. It can break. Once the soil liquefies, the pressurized water and sand force their ways to the surface. So the surface soil will fall into this liquefied zone. So we will see a huge amount of sand ejected. And we want to get rid of. So after removing the sand mass, we see the ground subsidence very clearly.
Well, you can see here, on all these walls are on a tilt. And you can see here, the original ground level was this. And the subsidence here must have been a couple of 10 centimeters, something like that. Here is another example of earthquake-induced liquefaction consequences. These two are manholes for an underground water tank. Any object having a big hole in it can get huge power to be lifted up in a liquefied soil. So these two things came up above the ground level. So meanwhile, the surrounding soil has subsided, maybe 0.5 meters or a little larger. So therefore, this is showing how terrible the liquefaction is. Any underground pipes can be cut off with uneven settlement. These two things are preserved as they are after the earthquake. Just not to forget the things that happened here due to liquefaction.
With the liquefaction of the ground, earthquakes increase the subsidence. They make the city even more vulnerable to flooding. In red on this map are the areas threatened by subsidence in the event of a big earthquake. The port of Tokyo is particularly at risk, yet it includes an industrial zone with chemical factories. Scientists are worried about this extremely vulnerable site. What would happen if the port was subjected to an earthquake, a tsunami, or a storm?
In this reclaimed area, the ground level is low because it was constructed 100 years ago or 70 years ago. And also, there is no countermeasures against liquefaction of the ground. But over this old reclaimed area, there are so many chemical industry factories located in the area. So for the case of storm surge, since the ground level is low, there are very strong risk for flooding. And there are a lot of tanks and storage of chemical materials in that area. So it is necessary to protect the release of chemical materials from this industrial area in reclaimed area of Tokyo Bay. But from my view, we are not ready. We are not prepared.
The level of the sea is rising. Climatic events are becoming increasingly violent, and at the same time, big coastal urban areas are sinking. this subsidence is substantially increasing the risk of flooding. All over the world, the lives of many people are now threatened by these impending environmental disasters.
So that led us to think, well, what other cities are vulnerable to these kinds of problems? So what we did was we actually took a study of all the cities around the world, and we looked at 136 cities that in 2005 had more than 1 million people that were coastal with a port. And we looked at how many people live in the 100-year floodplain. So that's the area that would flood, have a 1% chance of flooding every year. And we found there's 400 million people in 2005 living in these 136 cities, and 40 million, so 10% of them, lived in those areas. And we found that certain cities had very large areas in the floodplain. A quarter of these 136 cities are actually sinking. And when I say sinks, sometimes it goes down at 10, 20 centimetres per year, or a metre every 5 or 10 years. So these are huge changes.
Some regions are sinking faster than others. This is the case of Louisiana in the United States.
Is the Mississippi Delta. New Orleans is located in this area in here. And most of this land surface has been disappearing over the last 30 years. And all projections are is this will disappear. In the next 10, 20, 30 years, it will be gone. And so when this disappears, water from a hurricane could more readily impact the city of New Orleans. So the cities on the deltas are at risk, all of them. I mean, without question, and they're part of this list of 136 areas at risk.
If we look at the 20th century, in many ways, probably for many cities, the subsidence has been much, much more important than climate-induced sea level rise, because we're talking about metres of change when the sea has risen maybe 17, 20 centimetres in the 20th century. In the 21st century, we expect much more climate-induced sea level rise, and climate-induced sea level rise will affect every coastal city, not just the ones that are subsiding. So we expect sea level rise in the 21st century to be much, much more important than it has been historically.
Subsidence and sea level rise are making things worse in the same direction. So you may solve the problem of energy and global warming, you still have the problem on the land. So these two have independent drivers. They both relate to humans, but they're independent of one another.
Rising sea levels, ground subsidence, and the excessive urbanization of flood zones. At the beginning of the 21st century, floods have become the greatest threat to coastal cities. But what can be done to stop this dramatic ecological spiral? How can we protect our urban centers from flooding? Everywhere in the world, engineers, architects, and politicians are attempting to address this challenge.